primary product is called AMP. That stands for Application Management Platform. It's basically a tool for deploying and managing applications across a variety of different locations. The cloud providers, bring your own nodes, bare metal, doesn't really matter where it goes. The idea is that you can blueprint an application and deploy it wherever you like. And then once it's deployed, you can manage it through its life cycle, from the sensor, from the information that gets returned to you from the application running by AMP. So today I'm going to be using Cloudsoft AMP and a blueprint that we developed to deploy Hyperledger Fabric across a number of different geographies, specifically Bluemix in San Jose, Singapore, and London, and for good measure, AWS US East. So all four of those are going to be talking together. And just by a show of hands, if you don't mind, working out the shoulder briefly, how many of you here do know at least some about blockchain, and specifically what Hyperledger Fabric is? I assume a lot of you, because you came to the talk. So okay, good. So there's a decent familiarity with Hyperledger Fabric. Very cool. So I'm going to show you it deployed. Let's just get right to it. This is a live demo session. So what we're looking at right here is the home screen of the UI of Cloudsoft AMP. And we're going to go into the app inspector. And what we're going to do is we're going to view a live model of two different blueprints of Hyperledger Fabric that are deployed. Just before I do that, I'd like to use the object-oriented model to make this easy. The blueprint is like the class, and then the actual deployment of that blueprint is kind of like the object. So we've got this blueprint that AMP knows. It knows how to deploy Fabric. And then once you go ahead and deploy it, you'll have a real Fabric running, and our UI will show you all the monitoring information of that real thing running. And that's kind of like the object, the living, breathing version of the blueprint. So if we go into the inspector, we're going to see two different... Okay, good. It doesn't get cut off. So we see two different HLF, stands for Hyperledger Fabric, demonstrations. One on a single location, which is IBM's Bluemix Red Hat, which actually was just announced yesterday, and then one on multiple locations, the four I mentioned before. So I can actually walk you through, for those of you who know the components of Hyperledger Fabric, this should look pretty familiar. And just for reference, this is deploying the 0.6.1 release. We're currently working on adopting 1.0.0, and that's a fast-moving target, so we like to move along with it. And when that becomes a little bit more stable and ready to go, you want to deploy it, of course. But 0.6 has been around for a while, and we know it's not really changing or moving around, so it's easy to keep our blueprint up to date with what that is. So we're going to be looking at a 0.6.1 deployment. So in this cluster, you have a membership services node. That's something else unimportant for the membership services node. We've got the root validating peer. Now, for those of you who know, that's basically the peer that all of the other validating peers report themselves to, which gossips membership to the rest. Skipping this for right now, I'll talk about that later. And then we've got these four clusters of validating peers. One in London, one in San Jose, one in Singapore, and one in AWS Virginia, showing across things. And inside each of these, we have an actual cluster of peers. And to keep the demo small, lightweight, I only put one in each. You can put any number you want in there, but Fabric requires that there be four validating peers at a minimum for the consensus algorithm, so I decided to put one in each cluster in these locations. But these, of course, can be expanded to as many as you'd like, just parameterized. The blueprint doesn't care, it just takes a parameter value. Hit the validating peer cluster, and this will look the same in all of them. You know, it's just a different location. AMP doesn't really care, it does the same thing wherever, it's repeatable. We've got the validating peers in each. Yes, each one. Right. Now, digging in a little deeper, what's really happening, if you would like to know what AMP is doing, validating peer, is AMP is bundled with this thing called the container service, and basically what that does is at the locations you specify, it will provision the VMs for you, install Docker host on all of them, and then pull down the containers for Fabric running on those hosts. So that's what that's doing here. Earlier on, I may have, out of context, mentioned this idea of sensors and effectors. Well, let me actually show you a little bit more about that. So if we actually go all the way down to a validating peer node, in the UI we can see sensors and effectors. Sensors provide a bunch of information about that entity that's actually running. The host address, host name, the health. The fact that you see the green circles means that this entity is running the way we expect. And the idea that AMP is not just built to deploy Fabric, or that's to deploy any application, and we've made it work for Fabric. The idea is that the blueprint will specify some sort of method that it can then hold the actual infrastructure running the Fabric node and make sure it's healthy. So we'll run the status check on the container running, and when it's good, you don't have to care about that. Just it'll come back to you saying, yeah, green circle, it's running the way that it should. And if something were to happen to it, you would basically see a more red style indicator. And then, because there are both sensors and effectors that you can actually take action on the node, that's how a policy gets made. And basically the idea is that sensor information comes in, great. Effectors can do things, great. A policy is, given sensor, do effector. So if something, for example, were to crash, you can spin up another container to replace it. You can do things like that. Or not for this particular blueprint, but in general, if there's too much load, let's say, on a particular entity or region, you can spin up more resources. If it's being underutilized and you're being wasteful, kind of cool down. So AMP in general has a capability, and this blueprint has the idea of being able to replace nodes that are failing and things like that. So I'd actually like to show you, backing up, this is a multi-location, multiple nodes across the world. For a live demo, I actually have a chain code that comes with the Hyperledger Fabric repository that I actually did a little bit of extra work on to make it a little bit more interactive, and then contributed back to the Fabric repository, and I'm going to show it to you here with the UI on top of it. For the record, I'm going to be using the single location for this demo because it's a little bit faster. When I want a chain code invocation to happen, I want the results to be ready right now, not have to sit around. And the more nodes you create, the more distributed, there'll be more latency, because Fabric is good about a lot of things, but very fast responses is not exactly what it's built for. So I wanted to keep the demo environment simple to show you. So I'm actually going to show it to you on reducing this single cluster, which is a little bit more straightforward. It's basically just in IBM's Bluemix. We have a single cluster here of a root and 3 nodes and membership premises. It's simple. But if you'd actually like to see that, forgive me if I have to log in. This may kick me out. Okay, no problem. Just in a second. I want to show you that it's actually running for real and comparing the sensors that that provides with the OpenStack interface. So, for example, let's take the membership services node running here. We'll see the IP address. Hope you can read that, 10.105.0.30. Now we'll go into the blue box interface here, membership services. So these are actually, I'll filter for my name to some of my teammates also running on here. Cool. We've got what we expect right here, 10.105.0.30. Yep, that's it. And you can see membership services. So that is that node. So everything you see here in the OpenStack Bluemix was created and is being managed by AMP right here. So I'd like to go into the demo for a few minutes and talk about it a little bit. So this is me expanding. If any of you have looked into the examples of the Hyperledger Fabric repository, you should have seen, actually, I'll show you. You would have seen asset management, not written by me. Now, this was something that was there. Cool. I'll explain more in a second, but this is what I based it off of. And I went in and I just made it interactive. Made it so it's a little bit more fun or interesting to use. Fun's a good word. Interesting to use and show. And I'll just explain the context very briefly. You've got these 3, or actually 5, different users. You've got Alice, who deploys the chain code. Then Alice assigns Bob as the administrator. So Bob, as the administrator, takes a bunch of these theoretical assets, which are basically, I use a bunch of famous art pieces from after David Bowie passed. Unfortunately, he had a lot of art, and in real life, a bunch of his art was auctioned. So I took a list of that art and used it as the assets for this example. So you've got a list of these assets, and Charlie, Dave, and Edwina, our British CEO thought of that name. I have never met a person named Edwina, but I guess it's a real name. I guess in the UK maybe or something. Fine. So there's the 3 names, and they each own some of those assets. So that's using the same chain code that comes with Fabric. The actual chain code, the logic, and the smart contract is another word for it. I didn't change. I just kind of changed the applications interacting with it. Then I, by hand, and I say by hand because that's not necessary as much anymore, but I'll say for now that by hand I created a REST API to interact with this code and then generated a Swagger UI to use it. So basically we can see list, you can list the assets owned by an owner, and then you can also transfer the assets between them. So I set Charlie, David, and Lena. So if we go in here and we ask blockchain who owns what Charlie owns, we'll see a list of the art that Charlie owns. And let's say we want to give lot 07, the David Bomberg, Morsharanda, and that thing to, we want to give it to Dave, let's say. We'll go to the transfer, and we will, we'll do lot 07, Charlie's the owner. We'll acknowledge something you're possibly thinking of, like, well, if you could just say who the owner is, and it seems like God mode. Yeah, it is kind of God mode. We're using a relatively trivial example of chain code. You know, I could write whoever I want there, but you know, this is sort of simulating the situation where only Charlie has access to his certificates. Well, I'm letting this have access to everyone so I can do this demo more easily. But using Charlie's certificate to prove he owns it, we're going to give it over to Dave. So I'll send a request, and asset successfully transferred. And then, if we go back to Charlie's list, sorry for all the scrolling, lot 07 is going to disappear. Yeah, it's gone. Now it's top 10. Of course, if I want to, one last thing, of course, if I want to do this again, like I want to he wants to impress Lena and actually try to give it to her, well, obviously he shouldn't be able to do that because he doesn't own it anymore. Yeah, forbidden. Owner doesn't own the asset. Now, if you'd like to squint at a command line real quick, I can show you the debug output of the chain code actually running. So this is a nice, pretty way of seeing it. But if I move over to this abomination, this abomination over here, you'll basically see this is the chain code actually spitting out the certificates and basically the certificates of each asset and checking if it's owner. And so here you can see it actually queried the chain code, got the certificate back, and realized, hey, Charlie's not the owner. You can't do that. You can't transfer somewhere else. So this is basically the debug output of the chain code actually running on IBM Bluemix. 5 minutes left. Okay, so what I said before was that I did by hand. I generated the REST API. So I recently got in touch with and learned about Fabric Composer. And with Fabric Composer, and Catherine, would you like to come up and say a few words? So this is, I'm prompting it. Catherine Harrison, working on Fabric Composer, basically what they're doing is making what I said I did by hand a lot easier. Right? Do you want to use this?
Yeah, sure. Can you hear me?
Yeah. I'll say about 1 or 2 more sentences. So basically, then hand it over to you. So what I did by hand, Fabric Composer allows you to actually generate a REST API off of, well, what we did here is we used AMP to basically, I fired up a Fabric Composer, and I took their example on their website, and I basically built up the example and then deployed it to the same fabric that we were running my example on, and then generated a REST API out of that. So right here, what we're looking at is cutting out Fabric Composer generating a REST API for chain code that they provided an example for. If you'd like to speak more intelligently about it, I can give it to you now.
Yeah, absolutely. If you can hear me, I can just talk. Okay. Alright, so Fabric Composer is a set of abstractions on top of the Hyperledger fabric. And frankly, it could go on any blockchain fabric. What it does is it makes it much simpler for business and developers to speak the same language. So if you look at all that Mike has done, there's a lot of very technical Go programming that you need to be able to do. And what Fabric Composer does is it provides the abstractions that represent those business concepts. So very simply, that's assets, participants, and transactions. So what Mike was able to do is model out the business network. And he used the sample that we had for the property network, but he very well could have done the art auction example, modeling out the different types of assets, who the participants are, as well as the logic behind when transactions are allowed to take place. Another feature is there are access controls so that only certain participants can execute certain types of transactions. This is very much like the business networks that we're all part of today. So once you define that business model, it then automatically generates the APIs, which you see here, which you can then use to generate a skeleton app, to integrate non-blockchain systems. So instead of having to be a very talented developer like Mike, you can be an average, kind of bored at work, JavaScript developer with 2 to 3 years experience and actually start writing blockchain applications. When we developed our first application, it took us almost 3 weeks to write it in Go, to lay it all out. With Fabric Composer, we were able to recreate it in a couple of hours. Really, the base of it we had figured out in about 20 minutes with a little bit of tweaking. So this is a great way, as you're looking at how do I build applications on blockchain, build them with Fabric Composer, and then work with Cloudsoft as you're looking to deploy that on your global blockchain network.
Yeah, and my experience in the past few days working with Composer, you guys can hear me also, right? I don't sound like it. No?
I'll just hold it like this. Basically, yeah, so Fabric Composer made one side of this, developing the chain code without having to know Go, building REST API without having to actually build REST endpoints. That's great. But of course, it's nice to be able to maybe test that and run that on a Fabric running somewhere in real infrastructure. So taking Cloudsoft's ability to deploy it with Composer's ability to actually use it easily and well, that can be a pretty cool picture that we're going to look and figure out how to get done.
Absolutely.
Yeah.
Great.
Full circle. Once you have it, what do we do with it? Composer steps. So I think we have a couple minutes for questions.